Hey y'all, welcome back. This is part 2 of the HP 8640B signal generator videos. I don't know if you watched the last video. I tackled some of the mechanical problems that were going on with this. Two things that were wrong. I couldn't rotate the range switch. It was frozen, and that was due to petrified grease that was in the mechanism. So I took that all apart, cleaned it, re-lubricated it. Now it's working 100%. And I also had a problem with the fine tune. Wasn't working on the frequency tune selector on the main oscillator. And then again, the same thing. I took it apart and cleaned it and re-greased it. Now it's working. So we tackled those two main problems. But we left off. When I left off, I had a problem with the frequency counter. And I promised I was going to make another video, but between that video and this video, I kind of fixed it on its own here, and I'll explain what happened. When I had it on the low ranges, the frequency was showing the correct frequency, and then when I switched it up to the ranges, once I got to I believe it was 128 to 256, it was showing incorrect frequencies, and then every range above that was showing incorrect. And what I did is I traced it down to and let me show you here. I'll flip this thing around. I got out the service manual for it, and the service manual for this is phenomenal, by the way. But what I found out was wrong is when I was working on this range mechanism, one of these two connectors became partially unplugged, and this is the range switches that is used for the device to determine what range it's sitting in. And these are, see, they're not in there very good. These are just 16-pin DIP connectors, and they're not ideal for this situation. I wish HP would have done something better with that, but it just plugs into a socket there. You can see the socket in there. And it doesn't take very much force to get these to mate or unmate, which I found out because since I was putting this, see, even it's difficult to, there, it's in. But there's two of those connectors, and they don't hold very well. I was thinking maybe it's not possible to lock those connectors in place somehow. I was trying to think of maybe getting a zip tie in there around it, or maybe even a dab of silicone on the side to keep it from popping out again. But it's in there now. I think between me working on this part, and maybe this thing has been dropped in the past, even like the contacts aren't very tight. So I think even if you drop this on the bottom, this could jar loose. So it's something to keep aware of. But now that I plugged it back in, the frequency counter is working. Everything's back to normal. So can't do a video on that, but I do want to go through and go through the operation checks of all the controls, make sure everything's working. And then I want to go through alignment best I can. I don't think I have all the equipment for the alignment, but I'm going to try aligning it to the best I can to my ability with what I have. Another thing I noticed is the power indicator lamp is burned out. So I pull all you do is you pull this straight out. This is the power button, and inside the power button is a lamp. I'll show you. See, there's the bottom of the lamp. You pull it out. If I can get it stuck in here now. And this is a neon lamp. I don't know if you can see the two electrodes in there. But what I can do, I don't have any of these style bulbs with the base on them. But it looks like I should be able to desolder the two connections on this lamp, pull this old lamp out, put a new one in. I'm pretty sure I have small lamps like this, and I can refit a lamp in there and put it back together to get this to work, because this should be illuminated. And it just pushes in. Oh, now it's going to fall out. Okay. So again, like I said, we can go through and test this. And one way to test it is to set it to, on its lowest range, set it to 500 kilohertz. Yeah, approximately 500 kilohertz, that's what they tell you. And when you switch through the ranges, your frequency should double. So you've got 1 megahertz now, 2 megahertz, 4, 8, 16, 32, 64, 128, 256, 512, and if that is on the extended range, which I don't have that option. I don't have the frequency doubler. So I can't actually get that frequency on this range. What I'd have to do is back it off and jack it up. And there's the maximum frequency right there, 550. But everything seems to be working. Like I said, I got an output signal, and I don't know what is going on with this meter. As you can see, the meter is functioning. I don't think it's working on every range. Now it's going to make a liar out of me. It wasn't working before. There's one that doesn't work. Another thing with the meter, if I turn the amplitude right down to 0, it still measures about half. What is it measuring there? I don't even know what it's measuring. It's not 0. So I think I still have problems with meter alignment. The FM, let's try it. Seems to be doing something. I don't know if I have an FM modulated signal. I'm going to play with this more and do the tests. AM's working as well. I confirmed I got an AM modulation, but we're going to go through all the operator checks to make sure it's all working, and then I'll get back to you and see what we need to do here. Alright, so I'm going through the operation checks, and I think I've already found a problem. What I'm doing here is I was going through and checking the RF output, and I'm using the unit's own frequency counter input as a display device, and you can see that I got it feeding into itself. If I turn the RF on, I have it set for 750 kilohertz right now, 0.75, and I can tune it. So I'll leave it there at 0.75. I have the voltage set to about 100 millivolts on the 100 millivolts range, just like it said in the manual. And I am getting meter deflection here. So I'm feeding the signal back in, and when I switch through the ranges, you notice that it works. Now we got 1.5 megahertz, 3 megahertz, 6, and then when I hit the 8 to 16 megahertz range, it goes to 0, and the meter goes 0 as well. And nothing here on this range, nothing on this range. 48 megahertz on this range, it's correct, but my meter is not getting any output. The output is just not there. It doesn't seem I have any control over the output either. That's odd. That's really odd. I should be able to let's go back here. Let's go 8 to 6, 4. Okay, 6 megahertz. So all these lower ranges are working, and then when I hit the 8 to 16, I have nothing. Unless I jack up the output level. So it seems like we got a fault with the output. It's not producing an output on certain ranges. 16 to 32. If I turn it up, I get my 24 megahertz, but I have no control over. There's no control over the output. No control over the output. Okay, so 32 to 64, I have 48 megahertz. That shows correct. Again, no control over the output. (96 megahertz). I have a little bit of control over the output, not much. But yeah, it's messed up. When I get back up to the 128-256 range, seems I got some control over the output, not full control, and I have a signal. So something's going on with the output level. I don't think it's attenuator. I think the attenuator is working. I think it's maybe a power amplifier output problem. But yeah, this is what I'm facing right now. So I think there's something messed up here. If I turn up the amplitude on the last highest range, I can get the counter to lock in. But I don't have full power output. Alright, another problem detected. The output level, the metering. The test is set this for 500 millivolts, which I do. I have it set for halfway. It's sitting on the 5 mark on the 0 to 1 scale. And when I slowly reduce the amplitude to 300 millivolts, this meter should automatically switch to the 0 to 3 range, and the meter should start metering on the bottom scale of 0 to 3. So when I reduce this, I'm at 4, 3, nothing happened, 2, and 1, and that's as low as I can go, is 100 millivolts, and it didn't work. It's still stuck in the 0 to 10. Alright, so I just wanted to confirm the fault with my scope, and I'll turn it on. I'll tell you what I found here. Okay, from 0.5 to 1 megahertz, I have full control over both the entire band. When I switch it to 1 to 2 megahertz, I got full output on the entire frequency range. 2 to 4, same thing. Now when I hit 4 to 8, I still have full frequency. 8 to 16, I believe this is the one where it didn't work. So it works at 7.1 megahertz. I start cranking it up. Right around 11 megahertz, there's a switch that goes on. Right there. What is that frequency? 10.9, 11, 11.04. So there's this point where, and I can hear a relay clicking, and then the signal drops. The signal's still there. I can crank it up. It's just very weak. That's why it's not showing up on the frequency counter or the meter. So why is it doing that? I don't know. So I go continue up the band up to 17 megahertz. There's nothing, even though the signal does get a little stronger. Let's do 16 to 32, 14.3 megahertz. Keep going up, and when I hit 22 point something, it switches again and it turns off, loses amplitude. Let's try it on 32 to 64. The higher up I go, it just seems to drop off, and then 45 megahertz, it disappears. And it kind of comes back a little bit. It seems it's not linear. 64 to 128 megahertz. I got a really weak signal. It's definitely not putting out what it should be putting out. Try turning it up there, it comes back around 87 megahertz and then drops again at 89 where the relay clicks. So I don't know what's going on here. I opened up the chassis to reveal. Here, I'll reposition the camera. I believe it's something to do with one of these two boards, either the range switching board because there's 4 read relays here, and it seems maybe one of these relays are bad, or it could be a bad divider on this board. There's several dividers, and I was feeling around with my finger here, and some of these chips are quite hot. Not at the moment, but... So I'm going to look around here and see if I can figure out what's going on. I suspect maybe one of these read relays, there's 4 of them, and maybe one of them is bad. Because definitely the signal is being attenuated here before it gets to the output stages. And I think that's what's going on. But I'm going to dig deeper into this and try and figure it out. Okay, just a little bit of what I found here. I still haven't pinpointed the problem. I do have an issue in the high side here. Let me explain what's going on. This board is our dividing board. It's got all our emitter coupled logic. It's very fast, and it does the dividing down, divide by 2, divide by 2, divide by 2, all the way down. And what these switches do is they select in whichever divide they want to get the range they need. Now that produces, well, this is fed directly from the oscillator at between the let's see here, between the 256 and 512 range, and the 256 512 range isn't divided down, it's fed straight through. But if I click it down one range to 128 256, I have 128 256. This stage here divides that signal by 2 to give me a lower range, and so on. And if I need another range, it adds another divider. So that's what's going on there. Now this is all digital logic, so it's running at TTL levels, and it's all square waves. So when it comes out of the divider, it's a square wave, and it needs to be reshaped back into a sine wave. So that's what's going on here. And there's also bandpass filters that are for each different range. Now the bandpass filters, they don't just have one bandpass filter for each range, they have 2. One for the high end of the band, one for the low end of the band. And we are experiencing a problem in these bandpass filters in the high end of the band. And they're switched in and out with these 4 read relays. I haven't been able to figure out I have a schematic of the read relays, but I haven't been able to figure out the wiring of these. And I think they work in pairs. Either these two are on or these two are on to switch between the high and the low. And I'll just hook up the scope and we'll show you what's going on here on the inputs and outputs. Alright, so you should be able to see your scope on the screen now. What I'm going to do is turn this thing on. And right now I have it set for, let's get it set for 8 to 16 megahertz, and let's go in the low end of the band first. This is where we're getting a signal through, because my meter has deflection, and you can't see it. I got you zoomed out. Okay, there we go. My meter's got deflection, and if I go past 11 megahertz, I lose it. So this is the low band filter that I'm checking right now. And here I'll show you what's coming into the filter. And this is what's going out of the filter. Pretty much the same amplitude. Okay. Now let me go to that, switch it to the high band. I heard the relay click. Here's the low. What's coming in. And here's what's going out. Got absolutely nothing. So it's interesting that we have a higher amplitude when it switches to the high band than when it's on the low band. It's almost like it's being disconnected from the filtering. These filters are pi networks. They're with capacitors shunting to ground. And the output again is, that's the low when it's going feeding the signal through, and that's when it switches to high, the signal disappears. So what's going on here? Do I have a bad relay? I'm beginning to think maybe I have a bad capacitor in here somewhere. Maybe it's got a shunting to ground in the one section. I could easily test those with an ohm meter. I'm kind of suspecting that maybe a bad set of contacts on one of these relays, or maybe an open coil. But I've tried checking the resistance, and I'm getting pretty much consistent readings across these coils, so I don't think the coils are open. Do I have a bad divider? I don't think so, because it's working on all ranges. So as I go up through the ranges, we're getting the correct division. So I'm assuming this board is okay, unless there's a problem with the drive of one of these chips to this filter board. If we're losing our drive, the signal might be there, but it might be weak on driving the signal through. We might be the reason why we're losing it. So I still need to do some head scratching and figuring out, and I just want to give you a little update to what's going on there. I'm going to keep plugging away here until I find out what's going on. Okay, I just want to show you a few things here. The relays are getting the correct signals. Now the relay should be up high and powered, so it is. It's a 5-volt relay. And this one should be off now. And it is. And then this one should be on, the opposite relay. So the relays are getting the correct signals. They're being fed the right. I'm just not sure if they're working. What I'd like to do is power each relay up individually, but I won't be able to because they're wired in parallel with each other. But I'd like to power them up individually and check the contact resistance on them, just to make sure that I don't have a bad contact resistance on a read. Okay, just going through and checking these relays. Here's one. This is K3. I'm going to go across, and I got about a 140 milliohms, and when I activate the relay, it goes open. Close the relay. Okay, now here's its neighbor. This is K4. Close the relay. I got random megohms. Open the relay. Close it. I think this relay's bad. It's not passing any signal. Okay, let's try K2. It's open. Closing it. Or 30 milliohms. Open. Close. That relay's good. The last one is K1. Let's see here. Trying to figure out where to probe it. Okay. Open. Closed. So K4 is bad, and that would make sense too, because this is on the high side filtering. K4 is on the switching this in and out. So I got to replace K4. I think I might just redo all 4 of these relays and get them all brand new. This is a problem taking this board out. There's 4 coaxes on the opposite side, some wiring, so I got to remove, pretty much gut the thing to get at the connectors and disconnect everything before I can pull this board out. So that would be my next step, I guess. Alright, so after much struggle I got the board out. Actually it wasn't too bad, I guess, but it was, yeah, it's pretty fiddly. I just don't want to do any damage to this thing because it's such a work of art, and plus it's unobtainium. Got the relays out, 4 relays, and as far as I can tell, these are shielded relays. Drawn in the schematic, you probably wouldn't be able to see this. It's a pretty small drawing. They show the coil without a diode, and they show the contacts with the shield. So I'm going to look for a reed relay that kind of fits this form factor, has a shield, no diode, 5 volts. And then we'll see what we can substitute in here to get this thing working again. Alright, so it's a couple days later. My relays have come in. This is what I've ordered. 4 of these BFS-1A-05Es. I selected these ones because they have the identical footprint to the originals. Let's pull one out and have a comparison here. They do have the same pinouts, and oh, they don't. I thought these were shielded. I guess that must be the shielding pin there. There's one, I thought they would have an extra pin that I'd have to chop off, but I guess they don't. They don't have the correct. But they will work. These are a shielded relay. That's why I selected them, because they are the BFS. And they are 1 form A, which is, this is a 1 form A relay as well, the original. If you search this part number R2974-1, you can still buy these relays, but they were just over $20 a relay, and they only had 2 in stock. So I opted against that, and I ordered these, which they had plenty of stock. And this is a reed relay, shielded, 5 volt, and it has supposed to have the same form A, but this will work. And these were only $10 each, which is quite a bit of a savings. So I'll put these in the board. I might have to modify them a bit because the pin spacing is not identical, and I need to figure out the coil, The coil's easy, I can figure that out, but it's the contacts and whatnot I need to figure out. So I'll get these wired on the board, get them installed. Let's see here. Yeah, they don't quite match. I'm gonna have to do some modifications on the pins, but they will work. All right, so now that I got it back together enough that I can test it, I got the boards back in. I did all the plumbing underneath. Everything's connected. Let's turn it on and try it out. You have it powered up, and we are at the low end of the 4 to 8 band. Let's switch this to, actually let's get an output here first. Here's our output, and we have, I don't know what the meter reads. The meter to me right now is reading rubbish, so I'm just going to have to deal with what's on the scope. So we're at 3.7 megahertz RF output. Let's go up in frequency. And you can see that we go to the top of the band, everything's good. Let's go to the next range, 8 to 16. And we approach the 11 megahertz, it should switch over. And right there I heard the relays click. Go back and approach it again slowly. Goes down a bit and then it comes back, the relays are working. So that's good, but we don't have, let's try, see, it drops off, and the relay clicks in. I wonder why we're getting dropouts. You know, it's probably just a matter of this thing might need an alignment or a recal, and probably my cables here are crap. Well, you can see they are crap because all the noise is getting through, but it's working now and the relays are performing the way they should. So what I'm going to do is we're going to finish putting this back together, and I'm going to wrap this video up here. Fix this issue, the relays. I had one open relay. Now what I want to concentrate on is this meter. I'm not convinced this meter is showing me anything meaningful right now. I think it's just a bunch of random readings compared to the output. So let's wrap this up here. I'll call this done for this video. We fixed the relay problem, and one more thing that's off the list. So thanks for watching, and I'll see you on the next one. Take care.